So we just finished an entire unit on algebraic expressions, and that's what your quiz is going to be on today. And we learned for algebraic expressions things like what is a variable, what's a term, a coefficient, collecting like terms, distributive property, et cetera, et cetera. We're going to now shift gears a little bit, but not that much because it's still a related topic, and we're going to start talking about equations. I mean, you should always know those terms now, once you've learned them. So I can always ask you, like, what is a constant and stuff, and then you should be able to recognize it. Okay, I want to start by talking about what is the difference between an algebraic expression, which is what we just learned about, and an algebraic equation, which is what we're going to learn about today. So I will write an example of both of them, and I want you to be able to tell me what you think is the difference between the two. So I have 2x squared plus x plus 3. That's my expression. And then for my equation example, I am going to write down 2x is equal to 3. What's the biggest difference that you see between these two things that I've written down? Peyton? Exactly. And that's really the difference. If you see an equal sign somewhere in the middle of all of your terms, that tells you that you have an equation. And the way we solve that is a little different than expressions. When you were solving expressions, did you often end up with an answer that was a numerical answer, like a 2 or a 5? Or did you end up with these big long terms with a lot of x's and y's and things like that? Yeah, you were left with quite a few variables unless I actually told you what the variables were represented, right? Like x is equal to blah, blah, blah. For equations, we are going to get actual numerical answers. So we're going to figure out what the value of x actually is. And so that's sort of, I feel like students find that a little bit more satisfying because it's always nice to get an actual answer rather than, just these long, meaningless expressions. Okay, so are the steps of solving one-step equations. First, we're going to determine what operation is happening, and then we're going to do the opposite of it. We're actually not going to do some of these middle steps because I think that was more middle school. So I'm going to show you just ways to reduce the number of steps you're doing. And then step 3, you're going to solve the problem and write your answer. So let's start with 4 really easy examples. You're going to notice that I have drawn these obnoxious lines where my equal sign is. And that's because I want to tell you about mathematical format, which is really, really important. So I've been talking about format throughout our semester. I've been talking how you should always work down, never across. I've been telling you to circle, highlight, underline your final answer. For equations, it's really, really important that all of your equal signs line up. And so that's why I often draw a line just when we're starting to do math, because I want to make sure that your equal signs are always lined up. Will I take marks off if your equal signs are all over the place? Absolutely, because it's bad math format. Okay, so if it helps, go ahead and draw these lines. Sometimes you don't even need them, but sometimes it might help. You might find it useful. And when I'm solving equations, here's what I think about. I think that this line is a magical wall, and on one side of it, we're going to have our letters, and on the other side of it, we're going to have all of our numbers. So I keep my letters on one side, I keep my numbers on the other side. And the thing about this magical wall is that when something goes over it, it changes the operation. So if it was a positive to begin with, it becomes a negative on the other side. If it was a negative to begin with, it becomes a positive on the other side. So let's try that with this example. We have x minus 6 is equal to 12. We're going to keep the variable x on the left-hand side. We're going to keep the number 12 on the right-hand side. And what we're going to do is we're going to take that negative 6 and we're going to move it over to the other side. And when we do that, it's going to change its operation and it's going to become positive 6. Now you may be saying, well, this question is really obvious. I don't even really need to do any math. I can figure out that 18 take away 6 is 12. However, when we get to harder questions, you're going to need some sort of method to do the harder questions. And so this is sort of the method that always works. Does this sound familiar to when you guys learned it in middle school? kind of. Some of you may have learned it where you were adding 6 on both sides. We're not going to do that step. If you want to do it, you can, but I'm going to just avoid that step and just go right to the answer. Okay, let's try the next example. I'm going to keep my n on one side and I'm going to keep my numbers on the other side. So it's going to be n is equal to, the negative 8 stays here. When I move the negative 11 over, what will it become? Positive 11, good. And so my final answer would just be negative 8 plus 11 is positive 3. So n is equal to positive 3. And by the way, yes, we are still going to be boxing all of our answers. So make sure you're still doing that for your final answer. Yes, final answer. You can underline it, of course. Okay, so for this example, I want my x's to stay on that side. I want my numbers to stay on the other side. Do you need to label those? Nope, I'm just doing it just so you can see what's happening. And in this question, which I'm just going to rewrite over here again, we have 3 times x is equal to 18. What is the opposite operation to multiplication? Division. So in order for us to get the x all by itself and to get rid of the 3, I am going to divide both sides by 3. Why does this work? Well, what's 3 divided by 3? 1. Do we need to write the 1? No, you can just write it as x because that's 1x. So now you've gotten rid of the fraction there, the 3 over 3. And what's 18 divided by 3? 6. Now, this example just worked out nicely, but sometimes you won't end up getting whole numbers. You might actually, I don't know what I just did there. You might actually have a fraction that you're going to have to keep a fraction, and that's okay. Okay, the last question on this page. Again, we're going to keep our x on this side, and we're going to keep our number on this side. I'll rewrite it just so I can see it a little bit more clearly. We have negative 5x is equal to negative 20. How do I get rid of the negative 5? Yep. Fraction's fine. Yeah. How do I get rid of the negative 5? I am going to divide both sides by, am I going to divide both sides by 5 or negative 5? Yeah, I want to get rid of everything in front of the x, including the negative sign. So I'm definitely going to divide by everything in front of it. Negative 5 divided by negative 5 is just a 1x. What's negative 20 divided by negative 5? 4, and that is our final answer. Why did that not turn into a box? Okay, does that make sense so far? Okay, good. I'm seeing a lot of nods. Let's keep going. Now for the second page, we have something called multi-step equations. And all that means is now we're adding more steps to it. So you can read the little step 1 and step 2, and we're going to get right into the examples. Should we pause here for a second? All right, so you can see the next 6 examples are a lot more difficult than the ones we just did. Let's go ahead and try them. So the concept still applies. We're going to keep our x on one side. We're going to keep our numbers on the other. But these are called multi-step because it's going to require more than one step. Question? What's that? Not a question asked right now. I'm going to begin by moving the negative 5 to the other side. So I'm going to keep my negative 4x on this side. I'm going to keep my 15 on this side. And I'm going to move my negative 5 over, and it's going to become a positive 5. Now, I'm just going to solve as I go. I can't really do anything with the negative 4x right now, but I know what 15 plus 5 is. It's going to be just a 20. Does this question remind you of anything that we just did? We just did these types of questions in the previous page. So what are we going to divide both sides by to get rid of the negative 4? Yeah, I'm going to divide this side by negative 4 and this side by negative 4. And the reason I do that is because negative 4 divided by negative 4 is just a 1x. And 20 divided by negative 4 is negative 5. Good job. No breaks. Let's just keep going. Again, I want to remind you your x's are going to be here and your numbers are going to be there. Now, I keep putting the x's on the left. Does that always have to happen? No, you can gather your x's on the right. It doesn't matter. I just feel visually it's easier when it's on the left, but I will do some examples where we'll have them on the other side as well. Okay, so in this question, we're doing a double swap because I have a term with x on both sides. I have one here and I have one here. I want to try and move the 6x over to the left-hand side, and I want to move the positive 7 over to the right-hand side. And I also have to remember that every time I move something over the magic wall, it changes the operation. So nothing is going to happen to the negative 3x. It remains as is. When I move the positive 6x over, what will it become? Negative 6x, good. Then I have a negative 2 here, it remains. When I move the positive 7 over, what does it become? Negative 7. Don't know what's happening here. Oh my gosh, it's not letting me write. There we go. Are we allowed to add negative 3x minus 6x? Are those like terms? Yes, they are. So we are allowed to add those because they both have the same variable and the same exponent. And I'm allowed to add negative 2 minus 7. Those are both constants. To get rid of the negative 9, I'm going to divide both sides by negative 9. And I'm going to get x is equal to negative 9 divided by negative 9 is just a whole number 1. For those of you that were working ahead, are you getting the right answers? Okay, great. All right, we keep going. Ooh, this is a great question because look, we have a bracket. And what have we learned in the previous unit to do when we have that bracket? What's that? Yeah, we need to solve the bracket first. What's the word that I'm looking for? Exactly. So we need to use the distributive property in this question, distribute the 2 inside of the bracket. So we're basically going to distribute the 2 over here and over here, and that will help us get rid of the bracket, and then we can solve the question. So this is good practice for our quiz today. What's 2 times x? What's 2 times positive 1? Plus 4 is equal to 11. Now, the next part is really personal preference. I like to clean up both of my sides before I start moving things around. Some people just like moving things around. I see that I have a positive 2 and a positive 4. Those are both constants. So I'm just going to go ahead and clean those up to give me 2x plus 6 is equal to 11. Do you have to do that? Nope, not at all. You can move them over and then add everything. It's up to you. So I'm going to move the 6 over. It's going to become negative 6. This will be 2x is equal to 5. And finally, we have a question which does not give us a whole number. So when I divide this by 2 and I divide this by 2, I'm left with a fraction of 5 over 2. And there's absolutely nothing wrong with that. You don't always have to have whole numbers. Your x can literally be anything in the world. Which means like it could be decimals, fractions, whole numbers, anything. Yes. You can, it's just we don't have calculators, so I think it's just easiest to leave it in a fraction. If you wanted to put it in decimal, you could, but you don't have to. Yes. Yes. Last 3 examples. I'll let you guys do F on your own. Actually, no, I'll let you do E on your own. Let's do D together. So question D, we have to actually distribute 2 different times. We have a 4 over here that we're going to have to distribute on the left-hand side, and we have a 2 over here that we're going to have to distribute on the right-hand side. A volunteer to tell me what I would get when I distribute all of this and help you practice for the quiz. Nugent? Yep. Excellent. A volunteer to move the W's to one side and the constants to the other side. Sharia? Yeah, I always actually write whatever number was first and then whatever number I'm writing. So I keep the 2 there and then I move the 4. And now we can just solve. Am I allowed to add the 4W minus, or am I allowed to subtract 4W minus 2W? because they're like terms. So you can do that and you'll get 2W is equal to 6. And we're back to getting our perfect answers. Why did that why did that happen? It's because I have this on. It just turned into a 0. 2 and 2, and so W is going to be equal to 3. Okay, I lied. We're going to actually do 4 together as well. Sorry, E together as well. E has a little bit of a trick where you have to be slightly careful. Do you guys see this 4 plus 2? Am I allowed to add those numbers together according to BEDMAS? No, that is a very common error. When students see a question like this, they're very tempted to add those together and make it into a 6 and then distribute. And I'm here to tell you that that's a very huge mistake. Don't do that because you're completely ignoring the rules of BEDMAS. The rules of BEDMAS tell me that I actually have to multiply first, and that's the distributive part. So we are going to begin this question by distributing the numbers and keeping that whole number just on the side. So I'm going to have 4 plus 2 times x is 2x. 2 times negative 3 is negative 6 is equal to 3 times x is 3x. 3 times positive 1 is positive 3 minus 8. Again, I clean up the left and I clean up the right before I start moving things over. So I have 2x and 4 take away 6 is just minus 2. And then I have 3x here. Positive 3 take away 8 is just negative 5. A volunteer to help me solve this question. So begin by moving the x's to one side and the constants to the other. Priyanka? Yep, and on the other side? Perfect. Yep. So we moved the 3x to one side, it became negative 3x. We moved the negative 2 to the other side, it became positive 2. 2x minus 3x is negative 1x, something we've never seen before, but that's okay. And negative 5 plus 2 is negative 3. Now, even though there's no number in front of the x that's more than 1, it still has a negative sign, and we need to get rid of the negative sign. So we're just going to divide both sides by negative 1 because that gets rid of the negative 1 in front of the x, and we solve it to get x is equal to 3. All right, go ahead and try F yourselves. I'll write the solution. You can check to see if you got it right. Question? Oh, give me a second. I'll put the solution up and then I'll come and help you. Let's use. Okay, I feel like I'm going to have to squish this in a little because I wrote this part so large. Positive 8. I'm going to move that in a little. There we go. Why is everything disappearing? Super weird. Now I can't remember what disappeared. The 21 and the 2. I get x is equal to 3, so take your time, see if you get that as well. If you are done, there are a bunch of textbook questions that you're going to be doing, either for homework, or if you're done your quiz early, you can get started on that set. Yes. Okay, so I'm going to stop the recording there, and you guys can